architecture, but I can make you understand or make you at least get acquainted that how many programmable devices are there. Okay, so now provided given this type of things, okay, we can prepare a mask. Why? Because we know that ROM is nothing but a combination of a decoder and a electronic circuit where the switches can be made so that the word lines can be framed, and then from the word lines the functions can be extracted. And now each function that when we see whole together, we will say there are 4 bits. But in the bits also, each one we can take that as a function, and those are all the combinations of those min terms. Is that correct? So finally we can have a decoder, a mask, okay, switching mask, and the functions which are connected with the switches and who are combined with OR gates. Is that correct? In crisp, I can say that way, that one with ROM. Is that correct? Yes or no? Hello? Internet
Yes.
is there? Okay, fine. Okay, now another way is there, right? So sometimes these switches are also shown as cross. Okay, that one. Today I'll show another way how to create a switch. So for example, we have a word line like this, okay, and we are making a function. We can also show like this. Instead of that one, we can show a switch like this. Okay, this is also another representation. So if at all there is another word line, we can show like this. You can use different color pencils to indicate that that switch is maintained. Okay, but these lines are called word lines. They are coming from decoder. And decoder is nothing but it's an AND element. In fact, it's an AND element. Is that correct? Okay, so that means the inputs for a ROM is that we have to know what is the truth table. Once the truth table is known, then we can prepare a mask like this. That is what a ROM design, nothing much. Okay, so can I have can we discuss one problem on that? Right. Now let me show. Just a second. Just a second. I will show you the first one. Now, can you see the screen? Everyone, can you see the screen?
Yes,
Yes,
ma'am.
ma'am.
Okay, so now what exactly is happening there? It is a information prior given to you, provided to you. That means it is a task having 4 inputs, right? There is a hex equivalent of that, and then there are some A02, how much? A6 something is there. Some ASCII code is given, but this information is provided to you. The task is design a ROM. That's design a ROM. So now, since that information is already given to us, so our task is only to design a ROM. Now let's have a discussion. What can be the design aspects in that? So what are the inputs there? 4 inputs. W, X, Y, Z, I suppose. Yes? Yes or not?
Yes, ma'am.
Right? And then what are the output lines? So A0 to A6 are the output lines, and already the what information is there like ones and zeros, what has to be represented. We need not worry much about that. So we want to write this on a ROM. Okay, that means our first requirement is we require a decoder. Now tell me what is the requirement of the decoder size? It's a 4 input. So you will have 4 by 16. Is that correct?
Yes.
Yes, ma'am.
So now 4 by 16. So automatically this line will go, 6 lines will come, right? You can
Hello, ma'am. The video is stuck.
sudden drop. I'm so sorry. I cannot help. Yes, you people can listen to me.
Yes, ma'am.
Yeah. There is a sudden drop. So, am I internet? I think it has
I'm
been
not
internet.
audible.
Yeah, I'm not talking much. There's an internet issues going on. So for last 3-4 days, I think Zimbra is also not working, right? Hello.
Yes, ma'am.
Yeah, Zimbra is also not working, I guess, right? There is some server issues going on, and we are complaining also. Nobody is really listening here. So we are telling that please work out as quickly as possible. But who will listen here? We are all in the same boat. So am I in a meeting? You are able to listen?
Yes, ma'am. Now audible.
Now audible. Okay. So again, that truth table is visible screen.
Yes, ma'am.
Okay. So now we were discussing on that, right? Okay. So what we are trying to do, we are trying to design a ROM. So where we are doing, what is the first one? We require a decoder. Is that correct? So decoder is ready. Now next task is, we have to create a mask. Right? So now in order to create a mask, we already have an estimation of the truth table provided to us that we are having some A naught. So A naught, then afterwards like that we will go on, right? A1, something like that, A6, still A6 or A7, how much? I can't see. How much? How much is there?
A6.
6.
Six.
Pardon? 6 only, na?
Yes, ma'am.
Okay. So now the thing is this mesh. Okay, I'm not completing it. You can very well complete. So this word lines you can connect it. Right. Connect all the word lines. You have 16 lines. Take neatly pen and paper, nicely scale everything you keep, and then keep the lines ready. Right. So once the lines are ready, our task is to find out what are the terms that that contributes. What are the terms that contributes for A1? What are the terms that contributes for A1, A2, A3, everything? So we will try to jot it down. Then afterwards, what we can do? We can make the switches accordingly. So now, for example, A0. Can you just help me out? A0 makes like what all word lines are required in that? For A0? For A0, it's nothing but the summation of, yes, A0 is what? Summation of, I think 1, then 3,
1, 3, 5,
5,
7,
7,
9.
9. Then afterwards A means for us 10. Okay? Because it's in hex, na? 10. Then afterwards, see, 12. Then 14. Is that correct? Yes or no? Again, gone?
Yes, ma'am.
Yeah. So you can keep all those midterms. Then once the midterms are ready, so for example, I am just taking some few terms. Okay. So this is for 0, 1, 2, 3. Okay. M0, M1, M2. So M3 that goes on M50. So we have 1, 5, 7, 9, something like that. 14. Right. 14, 15. Example. Right. So now what we will do to make A0, it is having 1. We can indicate like that. I will use green. So this is also a switch. That means it shows that it is on. Okay, this is another representation. So M5. So maybe this is your M5. Consider this is M5. So you can make a switch. So 7, 9 like that. You can make a switches like this, and then afterwards A0 will be there. So you have to work out in between. So wherever that terms are there in the word lines, you can keep a cross. I think better than that switch, you can show it this. Is that correct? Is that fine?
Yes, ma'am.
Okay. So now, so I give the overall view, then how to make that. Okay. So now what it is happening here? We are trying to create only the mask of the requirement. That means the requirement is that of a hex inverter, and sorry, not inverter, hex law. So we are trying to only show that. So you can just see how it looks. You can use this type of switches, and then I'm sharing the screen. Everybody can have a glance at that. Okay, a 4 by 16 decoder, right? We have outputs and inputs shown here, and if you can see A0, A1, A2, A3, A4, A5, A6, A7, like that, you can continue. Okay, now 3, 4, then 5, 6 also is there, no? I think. How much I have given? The truth table shows
A6.
yes, 6. Okay, like that only. So I was just keeping that only few in that. Okay, you can keep everything. Okay, is that fine? I prepared only for A0, A2, A4, A6, A7, everything can be included. But A6, A7 anywhere is that? Like, are you getting any terms in that? A5 and A6. A6, all the higher end terms are there. And these are all lower end terms. Oh, it's very easy. A5 and A6. Okay, you can show that one also. Right? Is that clear? Yes, you guys are there or not? See, till only
Yes,
A4
ma'am.
is shown, then A5, A6, everything you can keep on adding that. It's just a glimpse. Okay, not means outputs like this and inputs like this. Okay, so this is only the design of a round. Okay, it's not like restricted. You can make any mask. Did you see the new sign for the switches? It is shown as a cross mark. That's all. Is that fine? That? Now. Yes. So this is just an example for how to design ROM. Given the truth table, we can prepare a program, mask for the requirement. So A0 to A4 only shown. You can add 5, 6, everything in that. Okay, so I need everybody to learn that. There's nothing much to learn. You need a decoder and a word lines to attach in that. Right. So now next comes the topic of programmable logic devices. PLD. We will say programmable logic devices. Now, if you carefully understand logic devices, we know what is the meaning of that. Logic devices are nothing but gates, or we can make it as a combinational circuits. They are also devices for us at present in digital form. Right? Now, what does programmable means? So, programmable means I clearly can visualize it is a task. Right? So, it is a task to perform on this one. Okay, now task means what? It's actually a work, or you can say that it has to have some application sort of thing. So that means we are preparing something, okay, on these devices. This is what the meaning, programmable logic devices. So the performance of a particular task is done on these devices. That is what is PLDs, right? So basically they are categorized into two sections. It is called PLA and PAL. Programmable logic array, programmable array logic. Very funny, the same words but repeated, but both are different. Programmable logic array. Okay, then this is programmable array logic. Right. They also fall in the, so prior to this is the ROM. ROM realization is the starting point. Then comes the PLDs, because we already know that ROM once prepared, it is fixed. We cannot rework on a ROM, but the next memories can be reworked. That means they are again and again reutilized, provided if we can program them. Okay, so under that category, I am talking about PLAs and PALs. Right. So now we will clearly understand what exactly is this PLA. In simple words, it also is like a ROM. It is also is like a ROM, but it is a combination of clearly understand. It is like a ROM only, but there is a missing decoder in that. That means we have a set of AND gates and a OR gates. Right? Now, why I use the word array? There are so many AND gates available to us and so many OR gates available to us. So, do whatever you can do in that. That is what the meaning of programmable logic array. A set of AND gates. That means in CRISP, I will say you will have some N inputs, right? Started with an AND array. I'm saying array means many. We have some lines coming out of that. We have OR array with us, and we have some M outputs. No link between these two. This is N and this is M. So we have a box of AND gates available to us. We have OR gates available to us. Do whatever you want to do. Program them, make the switches, and then perform the task. This is what a PLA does. PLA is a bank of AND and OR gates cascaded and given to us. Right? So, don't you think that this is also falling in the category of ROM? It is like a ROM only, but not ROM. Okay, carefully understand what the difference of a decoder. How a ROM is? A ROM is nothing but a decoder. Then afterwards you have a electronic mesh or a mask we will have. Then we will have output lines. But here what we are having? We are having AND array. Then combined with word lines, or maybe whatever comes out of this, we will connect to OR gates or array, and then we will get the outputs. Right? Please try to understand. These are the inputs. N inputs, M outputs. Are you able to follow? Any doubt in this? Please ask me now itself. Otherwise, if I proceed further, you will be having problem. Did you understand here?
Yes, ma'am.
Yeah. So a simple AND and OR array combination is making a PLA. So now I'll just show you a glimpse of that so that you can at least visualize. Okay, just a second. Right. Right. Now, this is what I'm trying to explain. You have AND array, you have a word lines, and you have an output lines. This is what called a programmable logic array. Okay, so now how this programmable logic arrays can be prepared. Okay, now I'm sharing you another sketch. Okay, this one you can easily understand, but afterwards we will try to analyze. Okay, so now let me stop sharing the screen. Okay, so now this is a PLA provided to us. Okay, but what is that given in that? We don't know anything about it. I'm so sorry. Am I there in the meeting?
Yes, ma'am.
Yes, ma'am.
Okay, so why I'm not able to share the screen? Just not why this screen is not got stuck. Can you see anything here? Now?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Now, this is some circuit provided to you. Okay. Now, clearly understand we have inputs, one section completely, and we have outputs, another section completely. Just an example. Okay, I didn't give you any truth table, nothing. This is only provided. This circuit is provided to us. Okay, so now this is a PLA. A programmable logic array. But what is the inference we are taking from this particular diagram? Right? And if you carefully observe your inputs, we have A, B, and C. That means 3 inputs are there. And if you closely check out inside, right? Like that A has 2 lines, one in a normal form, another one in a complemented form. Similarly, the input B has a straight line and a complemented line. Another one C is also having the same thing. That means the 3 variables are actually portrayed in a complement and an uncomplemented manner. Is that correct? Yes or not?
Yes, ma'am.
Yes, ma'am.
Right. Now don't check the other ones. Right? First concentrate here. Now what happened? There are some switching lines there. That means a switchings are prepared there. That means the AND array combinations are being prepared there. That what does it analyze? So it actually tells that we can program here, making an electronic contact or electrical contact or electrical and electronic contact, whatever it is. Preparing the switching mode means it's called programming. It is also called programming. Why? Because it's a hardware programming. So we are creating a soldering one, or we can say it is a chargeable, or through a laser they can prepare the switch. So some switches are already made, and that inference I can clearly show that on this lines that what is that switch made here, because the contact is A dash is there and B dash. So the combination is A dash B dash. Okay, so this particular input gives rise to the AND gate combinations. Already clearly understand. I told it is a PLA. That means first starts with end array. So make all the end arrays properly. Now clearly see the second one. The second line is A dash C dash. Is that correct? Third one, there is only B switching is done. Fourth one, fifth one. Please carefully check. Okay, don't get confused. Is that correct? Forget about the output section. Don't check into the output connections. Okay, now tell me, is that correct? The switching and the word lines preparation, is that okay? A dash, B dash, the switch and the switch is there. So I have prepared an AND gate between that. Is that correct? Similarly, AC dash. Similarly, B. Similarly, BC dash. Similarly, AC. Is that correct or not? Everyone? Easy?
Yes, ma'am.
Right. So now move on to the OR array. Now who is OR array? OR array is the next section. These word lines are going for the OR array. Now if you see, the outputs are actually grasped from the OR array with the switching combinations. Right. So the word lines are connected so that now F0 is nothing but a OR combination of first one A dash, B dash and AC dash. Do you agree for that? First one, F0. And F1 is a combination of AC dash plus B. F2 is a combination of A dash, B dash plus BC dash. F3 is a combination of B plus AC. Why I use the word plus? It is OR. Actually, it is OR. B or AC. This is the OR array. The meaning of a PLA is what? It is having AND array and an OR array. Please again go through carefully because after this I will analyze in a different manner. This is very simple. Only thing is a circuit is shown instead of a truth table. Is that correct? And only issue coming here is yes, guys are there?
Yes, ma'am. There.
Okay, easy. So a little confusing, but still just little clumsy and all. It's a circuit. That's what. Right? Is that it is easy, right? So now the next task in this programmable logic array PLA. Once this circuit is provided to us, immediately try to make a PLA table. Now, what is a PLA table? Okay, so you can see the board also. You can see the board or only the screen? You can see the board, right?
Yes,
Yes, ma'am.
ma'am. Visible.
Okay. So
Yes,
now,
ma'am.
now we will prepare a PLA table. Now, what is a PLA table? Very simple. Okay, a PLA table. This is called. Okay, this is not. This is next one. No? So I am removing this. First of all, we will master this. PLA table. Okay, now PLA table consists of inputs, right? Then consists of term, right? Then afterwards functions. Whatever, outputs. That means I will say outputs. Not this, outputs. Okay, now what do you mean by inputs in this problem? In the problem, the inputs are what? A, B, and C. Is that correct? That is what provided, no? It is given A, B, C. So now A, B, C. In this problem, A, B, C are the inputs, right? And the terms are nothing but the words prepared with the A, B, C values, right? So who are these A, B, C? They are present either in the switch on mode or it is in the off mode. That means it's like a complemented and uncomplemented form. If they are utilized, we will use the same manner of ones and zeros. A complemented means we will use 0, and uncomplemented means you will see 1. Is that correct? Already. Okay, so now ones and zeros are utilized to find out So ones and zeros are utilized to find out to express the terms. Is that fine? Right. So now let me show you how to prepare a PLA table. It's nothing but a 3-column. Okay, you can in fact see this also. Crisp. This is what till now we have. We have AND array, we have OR array. Then the functions are made. Okay, from the switches. Okay, this is another representation. Same one which I have shown earlier with the switches. I have shown like this. Okay, AND array, OR array. Now is it a similarity with your PLA? Is that correct? Can you check out the similarity? Same thing, the switches are there. It can be replaced like this. This is the second level we can show, much easier than the other one. Okay, so now the PLA table can be prepared the same thing, showing this. Now if you see, what are this? The inputs. Okay, product term. Other way around. Okay, I gave the term. Then after you can flip that also, doesn't matter. Okay, so now inputs are there and the product term is there. What is the term? Term means what? The first switch, whatever prepared is AB or A dash B dash. Okay, it is A dash B dash. So that means we will show this in a complement. C is not utilized. So we will show it a hyphen. The second one now available from the diagram is AC dash. So AC dash is A and C dash, B is not utilized. Right. Now third term is what? B. Only B is utilized. These two are not utilized. Right? I am showing that from the one B, BC dash. Now B, C dash, A is not utilized. Right? Then afterwards is. So this one is the inference of that big PLA electronic circuit provided to you. Then afterwards you can again show it in a different manner of AND and OR gates or array. Then this is a PLA table shown. Then afterwards if you check what are the output nomenclature I have given, F0, F1 I think. So F0, F1, F2, F3. So now F0 is made up of these two. Right? These two. So just the min-term combination. F1 is made up of this. And F2 is made up of this. And F3 is made up of B plus AC, B plus AC, B plus AC. So this is your PLA. We are not doing anything. We are only reading the circuit available to us. Is that clear? This one. The outputs, the inputs, and the product terms. Right? This is all the study taken from the provided version. What is that? Provided electronic circuit. Is that clear or not? This table. This is called the PLA table. Right? Now, right. So why you are silent? Any doubt you people can ask? Problem is done. PLA is prepared already. PLA is actually analyzed from the circuit. A table is prepared and these are the outputs. That's all. Done. You have programmed it. Is that okay? Is that easy or not? Internet is there, or am I in the meeting, or am I out of meeting? What?
Yes, ma'am. You're there.
I'm there in the meeting, but why no questions going on? Right? Abhishek, Ahan, Aniket. What? No questions? Nothing to question also. Very simple terminology only I'm using. A circuit is provided to us and we are analyzing what are the outputs. Right? Now, actual work will start. Now, can I reutilize this AND and OR to provide some other functions? Now, please participate in the discussion. Can I utilize? Because since I have a big AND array. In fact, I have what? 3 inputs and 3 inputs in both combinations, and I have some 8 AND gates available, and OR gates are also available to me. Can I program something else instead of this? That means, can I connect another circuit? Can I connect any circuit? Other circuit? Yes. Can I program for other functions? Yes.
Yes, ma'am.
We can program, right? So now how we can program? How we can program? It is a yes. I understood. But how we can program? How we can program is what? We have to rearrange the switches. That's all. We have to reconnect it. Is that correct?
Yes.
That's all. But our hardware knowledge should be much better. Okay, so that means we should have the tactics to how to make the electronic switches there. Then afterwards we can read something from that. That is what a programmable means. Very simple. These are all known things we are trying to recover or prepare on a hardware mode. Right, provided now this circuit is given to you, you should not be thinking that what exactly I have to do with this. We should at least analyze that these are the functions which we can retrieve from that board. Okay, at least that knowledge you should have. Is that okay?
Ma'am, please
Okay.
explain how switches are used to AND and OR expressions.
How switches are used for AND and OR expression. Okay. Are you talking about this? Okay. I'll take a small example otherwise. These are lines. Okay. Right? Now. Okay. So, still further I will increase. I have lines. Right? If I have a switch already. Okay, this one is there. From here. Right. So now this line, in this line, please try to understand. 1, 2, 3, 4. Okay. So now I have 4 connected. Okay. Some more should go. Okay. So now in this line, what are the switches available? First line. What are the switches available? What is the switch available? Somebody asked, na?
A.
Only A. In the second line, what is the switch available? Second line. This one is connected to third line. So second line, what is the switch available? Nothing.
A bar.
See, A bar is connected to the third line, Mama. See the line. This is third line. This is second line. See, okay.
So ma'am, first line also not connected in.
Yes, yes. Second one, for second line, nothing is coming and touching. This in fact is the switch between the first line and the A. Okay. Right? That means it is A. Correct. For the second line, there is no switch on that. A bar is connected to the third line. So here it is A bar. You check the word line and the variable line. So wherever they interconnect, that line only you have to take. That is what I have shown. Please try to understand there. It is shown clearly. Did you see the slide? Varieties of what show, I mean pictures will be there now. Okay, check out. This is what I think I have shown. I didn't change any slide. You just check out. In fact, I used this side switch and they have used this side switch. Means you can use any type. Okay, you see this switch. It is connecting from A bar to the word line. Is that correct? That's why A bar is used. B bar to the word line, first line. So A bar, B bar. Who has asked that question? Hiranmai?
Yes ma'am, I was asking that why A bar into B bar was coming.
Why A bar into B bar is coming? Because in that word line, two switches are there. So A bar into B bar. I told first it will start with AND N. So AND combination of the two switches.
Okay ma'am.
AND combination. That is what. See, please understand. It is a PLA. PLA means it is first AND array. Then comes the OR array. So AND array is created from the switches available to that. That's what I told. Please understand here. The switch lines. Okay, from where to where they are connected and the word line. Seems to be very pretty, but understanding is a little hectic here. First, second C, A, C dash. How it is done? A line is connected to the first, second word line and C is connected, C bar is connected to the next one. So then only the switch AC bar is made. Okay. Everybody understood or only one question? Has you people really understood? Huh? Now you understood everything, everyone?
Excuse me, ma'am, that arrow direction in the switches, ma'am, what does it actually signify? Flow of information in that direction.
No information regarding the arrow. There are so many ways to show. That's why today class starting I was telling that there is another way to show with a cross mark. So cross mark is what? Cross mark is nothing, no? It is not showing a direction also. It is only telling it is occupied. Is that correct?
Yes, ma'am.
That so see different notations. That's all. Different notations. I am using this side. That means I just have to indicate this line and this line are connected. Okay, if I don't show that indication, nothing is connected. This is only notation for us. Are we going to really make that type of arrow mark there? No. We have to electronically connect it. Wire. You will say wire. No, wire means you will draw a straight line. Or the wires are after the circuit, it is a straight line or what? No. It's an indication. So either you say a cross or you can say this. You can in fact say, for example, this one, a cross mark here. It is also here. Doesn't matter. Is that fine? Hiranmai, you are about to ask something.
Yes ma'am, then why in F0 these are ORed? Because they are also the two switches are there.
Why? What is that? What is that? Please come again. I mean, your voice is. Why?
In F0 the expressions A B bar and A bar C bar or B much ORed. They are plus. They are also two switches are there.
In the first half. See, in the first half, it has to be only AND. This is one block and this is one block. It is not a complete circuit. The circuit is having two portions. The first portion is the creation of the AND array. This one is again taken back to this one. There is a division between these two. We cannot use ORs here. We can use OR only in this one. You can see how the background I have shown. This is a separate one, this is a separate one, but they are wired. That's all. This is what you are asking. Hiranmay?
No, I was asking when in AND array, A bar and B bar are multiplied because two switches are connected to A bar and B bar. In OR array, although the switches are connected to 2, they are making plus sign. Why not AND sign?
Because it is in OR array.
Means by seeing the switches, we
You are not seeing switches. In fact, that is what I was trying to explain. You are seeing on the same board, but there are two different flags there. Okay, did you see that? I have told it's a combination of AND and OR. It is a combination of AND and OR. See, till here it is separate. Okay, now let me show this. Yes. See, it is blue. You can see the blue lines. I mean, blue black backgrounds. This is one section, and this is another section. You are telling that in the OR array, this all has to be OR only. Why not AND? You are asking. How we can perform an OR AND operation in an OR operation is fixed one. This section is meant to do only OR. Whatever availability is there, I have to only OR it. This side section is only meant to do AND. Why don't mix up these two? These two are separated. If you see carefully, the background is blue. Separations are there. Though you see that it is in the same board, but it is having a separation. Hiranmay, are you able to understand now?
yes, ma'am. Yes.
This is inputs coming. These are only AND. They have to be supposed to do only AND. It is fixed. Then afterwards OR. Then the meaning of that schematic diagram is completely wrong. PLA. It is a combination of AND array and a OR array. That's it. Wrong. It is a combination of decoder and the mask circuit which can OR all the word lines. That is what a ROM is. This is all a fixed structures. You cannot juggle with that. Is that clear?
Okay, ma'am.
So now there is some more information, right? There are some more logic circuits available to us which is not in the regular logic versions. Like I will tell you, have you ever come across a gate like this? Clearly understand. Have you ever come across this one? This is called buffer. Buffer gate. What its importance is? It takes a normal input, provides its normal output as it is, and its inverted output at this point. So exactly, it can do the operation of a normal one as well as an inverted one. Okay, this is called a buffer gate. This is a little advanced gate considered or prepared after taking the PLA structure into considerations, because in the PLA structure, if you see what is happening, you have a normal input and afterwards you are using a NOT gate and you are using this. Didn't you see that in the PLA structure just now? You have a normal line, you have this one. Now, if this is replaced by this buffer, I need not waste this many lines to prepare. If you can clearly understand. Observe this. I wanted to use in this place this particular one, a buffer gate, instead of a straight line, and a straight line means a complete normal version and a NOT version, separated. So if I don't separate and I use a tri-state buffers, like I will say a buffer gate, so we will have regular and this buffer output, complemented output at the same point. This is what the key device of your PAL, programmable array logic. So PLA, from PLA I have already moved to PAL. Nothing much difference. In the PAL, the actual inputs who are coming from the regular and the inverted versions are mixed up, and we use a buffer gate instead of a one. Is that okay? So that means we are having first all these one shuffled. Now we have regulars and complemented. All these things are made. Then afterwards, OR gate is already there. That is what called programmable array logic. Okay, so in fact, the crisp word in order to explain this PAL is that the device is changed. What is changed? The device is changed, and what exactly happens with the device? What exactly happens with the device? The devices are using buffers instead of regular gates. Please try to understand what is a buffer means. A buffer is nothing but a circuit or a logic gate which can provide the regular version, its uncomplemented form and the complemented form from the same gate. That is what called a buffer is. Are you able to understand that? So PAL, which is nothing but the programmable array logic, is having a normal output and a inverted output from the same one, from the same gate. Okay, so that means which we can say the AND array is programmable and the OR array is fixed. Okay, so since we are using this one, I will try to show that particular concept here. Just a second. Now, just an example. Okay. Now you will understand what exactly I am trying to tell. So this is just an example I am showing. It is having two buffer gates, and now the two inputs I1 and I2 are there. They are all connected. Okay, that means how many connections are there? Two gates are there. Means I will have four outputs. Don't see this F1, F2 at all. Okay, please. For time being, don't look into that. So this is a regular version available to us. We have all these fixed structures, right? So what are all the possibilities? They are maintained. Okay, so buffer gates are used, this and all, right? So now this one is called a unprogrammed structure. A unprogrammed structure, and this one is called a programmed structure, where this switches are there which indicates that something is happening with this. Now if you carefully observe this one and this one, you will understand what exactly the programming is. Okay, now if you see here, this switch and this switch, what is happening? These two switches, they are entering into the AND gate, right? And these two switches, they are also entering into the AND gate. So then afterwards the OR gate came. But how the expression has been coming here? I1 F2 plus I1 dash, this one. How did we get this? Now follow this one carefully. What is this line? This is I1 line, right? You guys are there or not?
Yes, ma'am.
This is I1 line. This is I1 dash line. This is, what is this line? I2 line. This is I2 dash line. Please try to understand this. Okay. You can see the board outside. I1 is coming. This is another one. Now 4 dedicated right. So in fact, if at all these lines are just made already. Okay. Right, afterwards I'm not explaining that one. First of all, you understand the meaning. Okay, if I make here, what does it mean? Here. What is? Hello? Am I in the meeting? Don't check that. Okay, let's
Yes,
stop.
ma'am.
I'll stop sharing. Check on the board. Check on the board. If I make a cross like this here, okay, this one I'm not doing right now. Just a minute, normal line. What does this cross means? These switches are used, no? This cross indicates switch or not?
Yes, ma'am.
Okay.
Yes, ma'am.
So now
Yes,
from
ma'am.
this switch, what is coming? I1. From this switch, what is coming?
I1 dash.
I1 dash.
I
That's all.
wonder.
So now here, consider I have an AND gate. Okay. So AND gate is provided to us. So now what is coming here?
Zero.
This is what provided. I1 and I1 bar. What is that value? I1 A into A bar or I1 into I1 bar. What does it mean? What will come?
Zero.
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 Yeah, whatever it is. So here they are connected like this. Consider it is connected. Okay. So now what does the star indicates? The star indicates switch is made and then it is allowed. Switch is made and it is allowed. Okay. And what are the vertical lines means? Vertical lines are the actual combinations. Now similarly, if at all I'll make here another one, right? And I have an AND gate. What is coming out of that AND gate? Only
I2 dash.
that's it. Because this is how made, right? So that means here this first section, this section you forget. This section will give the indication of what all are allowed inside, right? So now, first of all, in your whole unprogrammed version, they will have all the combinations available to you. Means you will have what all permutations, not permutation, combinations that can be made from an input is completely available. Afterwards, we have to do programming. That means whatever switches are required, we can program it. That is what I was trying to show there. Please don't check the second one. First check the first circuit. Okay, it's a little confusing. Please you go step by step. Only see the unprogrammed versions. What the unprogrammed version has told you. It is telling that you have 2 buffers and you have 4 combinations, right? And all the combinations are connected to AND gates, right? F1, F4, then F5, F6. Some names are provided to you. This is everything available. It is an unprogrammed skeleton provided to you. Is that fine? Okay, from where it has come, don't ask me. It is provided to us. It is a circuit provided to us. Okay, so now we are trying to program this for a particular task, right? And if at all I do like this, what exactly is happening? We are having the lines, indications. So I1 is there and I2 dash is there. Okay, second line. Then afterwards, for this first AND gate, this is what? This line is what? This is coming from I1 and this is coming from I2 dash, right? So this is for the first AND gate, and for the second AND gate here, this is first. This is I1 dash and this is I2 regular one. So for this gate and then combination. Now, did you understand a program and unprogrammed differences between these two? These two are not at all connected. Please try to understand. These two are not at all connected. They are not connected. This is a separate ones. Are you able to recognize the difference between these two? These are different, this is different. Did you understand the programmed one? Are you able to do or not? Understand or not?
Understood.
Yes, ma'am.
Understood? Totally. Okay. Good for you. If you have
And
understood.
what is the use of AND gate if we are only giving one input? One input line is going in the AND gate in the
Yes,
program.
that's how we are utilizing that. Now the actual question came. Right? What is the gate of, what is the use of a 4 input AND gates? Correct? Now it is like this now. Right? That's why the word programmed is used. It means you are given the raw material for all combinations. Whatever possible combinations are there, everything is provided to you. Right? So all those, in fact, to be frank, what is shown here? Just a second. It's like this. It's this gate. Okay. And it is equivalent to, it's like this. This one is there and it is shown as single gate. Means utilized. This one is the 3 input and it is taken like this. Example. I'm just showing as an example. 3 input AND gate. That means all the switches are utilized and ABC has come. In fact, if you wanted to use, it has a 3 input, but you wanted to use only AB. Just remove the switch. Only AB will go. Easy? Understood or not? Somebody has asked, some girl. What? Have some reaction here. Damn with this classes. If you want to use that terms means you have to connect it. That's all. Who has asked?
Yes, ma'am, understood.
You understood? Good. So, if at all you want to connect it means that's what you are provided with all the combinations. What is the use of taking that 4 input etiquette? It is available to us. Don't use it. That is what if you want to use, that means using itself is called programming. Okay, the difference between your PAL and PLA is the buffer gates what we use. Other than that, nothing else. Okay, so now at least you should be able to understand that there is an option called memories and programmings. Okay, so programming is nothing but the creation of your switches. How you have to express. Now this expression is made. If from the same one, can I make another expression? Because I have already the raw material available. I can reutilize it, no? I can erase this and reutilize for another expression. Is that correct?
Yes, ma'am.
That's
Yes, ma'am.
so electrically erasable ROM. This is what a PAL is. See, these topics are, say, you are in a quest to do some numericals and all. But all the time numerical is also not correct, no? So combinational circuits you should at first understand. This is all theoretical concepts. I am giving you theoretical concepts of the memories. Okay, so you are always thinking that, okay, problem will be provided, we have to work out on that. No, it's not like that. At least you should understand that this erasing, this switching, this masks, everything is, this is actually theoretical classes. Last 2 days, I am giving only theoretical classes, not a numerical. Please don't keep that in mind. Okay, so different functions. Now, what are the possible functions that are available from the mask? Many possible functions can be made. Is that correct? So, if I buy this type of things, how many tasks I can create? I only have to get the art of making the electrical switches. Is that correct or not?
Yes, ma'am.
That's all. So if I thought I will have a 3-input buffer and then a big circuit available to me, I can create so many functions. Is that correct? Multiple tasks.
Yes, ma'am.
That's what. So that is what called, because ROMs and PLAs, PALs are not actually fixed. They are created for that. The manufacturer will have a particular design. Okay, since this is available, okay, we will do this is soldering. These are the tasks. That's all. So this is how it is done. We have all possible availabilities and array is there. Why an array is provided? We can in fact remove some of the gates and go for cost minimization. So everybody needs us something. That's why all the possibilities are provided to us, and depending upon the task, that gates only are soldered, electrically connected and then given. Is that clear? Because we have a lot of hardware available to us, because arrays are there with us, and array, or array, all these things. Is that correct? Hello?
Yes, ma'am.
Okay, right. Okay then. You can leave.